Good day, everyone. My name is Princess Mae Jotojot, and today we're going to discuss the basic concepts of graphs and tree search.
First is a graph. A graph is also a mathematical nonlinear data structure which can represent various kinds of physical structure. It consists of a group of vertices or nodes and set of edges that connect the two vertices. Vertices on the graph is represented as points or circles, and the edges are shown as arcs or line segments. An edge is represented by E open parenthesis VW close parenthesis, where V and W are the pairs of vertices. Removal of an edge from a circuit or connected graph creates a subgraph that is a tree. The graphs are classified into various categories such as directed, non-directed, connected, non-connected, simple, and multi-graph. Computer network, transportation systems, social network graph, electrical circuits, and project planning are some of the applications of graph data structure. It is also employed in management technique named as PERT and CPM, in which the graph structure is analyzed. A graph is collection of two sets of V and E, where V is finite non-empty set of vertices and E is a finite non-empty set of edges. Vertices are nothing but the nodes in the graph. Two adjacent vertices are joined by edges. Any graph is denoted as G equals open curly braces VE close curly braces, such as the example shown. Properties of a graph. A vertex in a graph can be connected to any number of other vertices using edges. An edge can be bidirected or directed. It can also be weighed. In a graph, we also use various terms like adjacent vertices, path, cycle, degree, connected graph, complete graph, weight graph, etc. Let's understand some of these terms. Adjacent vertices. A vertex is adjacent vertices. A vertex A is adjacent to vertex B if there is an edge AB or BA. Path. A path from a random vertex W is an adjacent sequence of vertices. Cycle. It is a path where the first and last vertices are the same. Degree. It is a number of edges incident on a vertex. Connected graph. If there exists a path from a random vertex to any other vertex, then that graph is known as a connected graph.
Tree search. A tree is a finite collection of data items usually termed as nodes. As it is mentioned above, that a tree is a nonlinear data structure which arranges data items in sorted order. It is used to show a hierarchical structure between the various data elements and organizes the data into branches which relate the information. The addition of a new edge in a tree results in a formation of the loop or circuit. There are several types of trees, such as a binary tree, binary search tree, AVL tree, threaded binary tree, B tree, and etc. Data compression, file storage, manipulation of the arithmetic expression, and game trees are some of the application of tree data structure. Tree is a finite set of one or more nodes such that there is a specially designated node called root. The remaining nodes are partitioned into n is greater than or equal to 0 disjoint sets. T1, T2, T3 to Tn, where T1, T2, T3 to Tn is called the subtrees of the root. The concept of the tree is represented by the following figure. Properties of tree. There is designated node at the top of the tree known as the root of the tree. The remaining data items are divided into disjoint subsets referred to as subtree. The tree is expanded in height towards the bottom. A tree must be connected, which means there must be a path from one root to all other nodes. It does not contain any loops. A tree has n-1 edges. There are various terms associated with trees, such as terminal node, edge, level, degree, depth, forest, and etc. Among those terms, some of them described below. Edge, a line which connects two nodes. Level, a tree is partitioned into levels such a way that the root node is at level 0. Then, its immediate children are at level 1, and its immediate children are at level 2, and so on up to the terminal or leaf node. Degree. It is the number of subtrees of a node in a given tree. Depth. It is the maximum level of any node in a given tree and also known as height. Terminal node. The highest level node is terminal node, while other nodes except terminal and root node are known as non-terminal nodes.
Graph versus tree. Graph is a nonlinear data structure and tree is also a nonlinear data structure. Next is graph. It is a collection of vertices or nodes and edges. Also, tree is a collection of nodes and edges. And next, graph. Each node can have any number of edges. So, there's no limit number of edges sa graph. Then sa tree, general trees consist of the nodes having any number of child nodes. But in case of binary trees, every node can have at the most 2 child nodes. So sample dani sa binary trees, ang nagkonsist siya og 2 child nodes, which is ang sa left is ang less than sa root, then ang sa right is ang greater than sa root node. There's no unique node called root in graph. Then there is unique node called root in trees. So mani pasabot ganina sa binary trees nga nasa jay root node. Mani dani magdepende ang duha ka child node niya. Then a cycle can be formed. Sa graph there's a cycle formed. Then in tree there will not be any cycle. For finding shortest path and networking, graph is the best application used. Then for green trees, decision trees, the best application use is tree. Conclusion. Graph and tree are the non-linear data structure which is used to solve various complex problems. A graph is a group of vertices and edges, where an edge connects a pair of vertices, whereas a tree is considered as a minimally connected graph which must be connected and free from loops. That would be all. Thank you.